Good morning, ladies and gentlemen. And we have ladies in the audience, so don't worry. Okay, welcome to today's webinar entitled IPv6 Plus. IPv6 Enhanced Innovation, Policy Makes Practice, Practice Makes Perfect. IPv6 was born more than 20 years ago. In recent years, with the continuous improvement of IPv6 readiness in mobile phones and OTT application, the IPv6 deployment for carrier network has also gradually accelerated. Let's see what's happening in IPv6 industry. Our speakers for today are Mark Oliver, Global Consulting Director, Service Provider and Communication, OMDIA. Welcome, Mark. Bokar Ba, CEO, SAMENA Telecommunication Council. Dr. Bilal Jamousi, Chief Study Group Department, ITU. Muhammad Zar'ouni, Executive Director, Policy and Programs Information and E-Government of TRA UAE. Latif Ladid, Founder and President, IPv6 Forum, Chair of ETSI, ISG, IPv6. Robin Lee, Internet Architecture Board Member and IP Protocol Expert. Carson Rosenhobel, Managing Director and Co-Founder of European Advanced Networking Test Center. Majid Nakbi, Head of Technology of Operation at Du Emirates Integrated Telecom. I hope he will join us later. And now for today, our first speaker will be Mark. Mark is yours now.
Thank you, Tony. Hopefully everybody can hear me. So it's great that everybody was able to join us on the call this morning. My name is Mark Oliver. I'm Senior Consulting Director for OMDIA, focusing on our consulting work across the telco service provider landscape. Using OMDIA's ongoing research and analysis, what I want to do over the next couple of slides is share with you some of the key thoughts and observations that we see regarding IPv6 industry trends. I want to specifically look at, where are we right now with IPv6? How have we gotten here? And what is it that needs to happen next? So I think, quite simply put, there's a fundamental truism now as an industry that IPv6 addresses are running out. And what we can see from the bar chart on the right-hand side here is that Europe and the Middle East have already run out. So there are no addresses left in RIPE NCC. Other regional registries have only a limited amounts left. And certainly while that, for APNIC in Asia, that issue is somewhat academic as they are moving fastest to 5G and therefore migrating to IPv6 as a matter of course. Certainly continuing with IPv4 is going to slow the adoption of IoT, 5G and additional consumer internet. So whilst the service provider can do some IoT and 5G with NAT and IPv4, it's going to be a very limited amount of service delivery, resulting in a very limited strategy for the service provider. So if that's the background, where is it that we're heading to? Well, the industry's collective wisdom has already selected IPv6 for the future. The Internet Access Board in 2016 advised all standards groups to focus on IPv6. And it advised that future IETF protocol work will, and I quote here, optimize for and depend on IPv6. And since that advice in 2016, certain countries have very much taken the IPv6 mantle and led the way. In the US, the government has made the mandate that we see here on the screen, and that mandate is designed to result in 20% of IP-enabled assets being IPv6 by the end of 2023. Moving up to 80% by the end of 2025. In Saudi Arabia, the CITC and its task force are continuing to work with RIPE to host training sessions and workshops to help promote IPv6. One of the results there is that Saudi Arabia is now the second highest in the Middle East for IPv6 adoption and the 49th globally. In the UAE, and one of my speaker colleagues we'll be talking about this in a lot more detail later in the webinar. But in the UAE, the TRA there, again working with RIPE, has been very active and driven these service providers to migrate quickly. A very clear goal in mind in the UAE, which was to prepare for mobile transformation, including preparedness for IoT and smart cities. And what that's resulted in is, as of this month, Akamai measures UAE IPv6 adoption at 30%, making it the highest in the Middle East region. And then the Indian government, it's taken a very ambitious approach as well. Reliance Jio is helping India to have over 60% of their connections being IPv6. And the government mandate there has in part been motivated by helping local firms to therefore position themselves as consultants on a global basis to support IPv6 implementation and migration around the world, generating new economic opportunities for itself. And I think if we take an overall conclusion from this slide, it's, where the government gets involved, it's proven to pull the market along. Proactive leadership at a government and policy making level can make a real tangible difference. And whilst it's not the only component of the formula, it is a very important catalyst. If we take a step back and widen the lens a little, what does kind of general state of early adoption look like at a country level? Well, what we're looking at here on this slide are the number of connections that are IPv6 versus IPv4. And the way to read this slide is the scale runs from grey to orange. The grey end of the scale denotes a prevalence of IPv4, and the more orange shows more IPv6 connections. So it's going to be the requirements that drive IPv6 migration. So what are they, and what is the pace of change and the pace of demand that we're talking about? Well, the first fundamental point that we see on the slide here is that there is a limit of 4.3 billion IPv4 addresses, and we have 5 billion mobile customers globally. So there's a clear, disconnect between the kind of the simplified supply and demand. Mobile operators have been the quickest to move to IPv6, and if we think for a moment about the characteristics of mobile operators, they of course have the issue of multiple devices on their network. These are moving around by very nature, and IPv4 is limited. So the move to IPv6 gives the mobile operators end-to-end control, meaning that the application can talk directly to the servers. We'll come on to a couple of specific case study examples on the next slides. And then just a quick observation regarding some of the kind of latent reluctance to migrate to IPv6 from some telco service providers, which is largely based on cost. And certainly at OMDIA, we think that IoT is going to be, one of the killer applications that triggers migration, and certainly our industrial IoT absolutely needs this connectivity. And we can see the forecast growth of industrial IoT on the chart here. So whilst there is a revenue opportunity associated with IPv6, which should be motivating the service providers, there is also this cost exposure risk associated with IPv4, because if the service providers aren't doing more on IPv6, they're going to be having to do more management on IPv4, which is going to increase costs and complexity with regards to the running of the network. On this slide here, we can see some of the examples where service providers are already adopting IPv6. I'm not going to go through each of these in detail, but just to pick out some of the highlights, I've already touched on the mobile operator constituency. Reliance Jio have moved in this direction because they had so much growth when they started to offer 4G services, plus their content service providers are already delivering content through IPv6, motivating Reliance Jio's own migration. We can see, broadband mobile operator like Telus in Canada, they're adopting IPv6 to future-proof their network, gain network performance improvements, and there are certainly operational efficiencies associated with the fact that IPv6 addresses are easier to manage. In Swisscom, the motivation was to simplify the management of the transport network between the broadband network and the broadband network gateway. In Belgium, a slightly unique story, which was more regulatory led. There was a ruling there that there should only be 16 subscribers for each IPv4 address. Thus the NAT solution in Belgium was very limited. Belgium made a kind of a universal, unilateral decision to say, let's go to IPv6, resulting in making it a world leader. I think the overall concluding point here, if we look at the kind of the themes and the trends through what's motivating service providers in adopting IPv6, it's the opportunity to access new areas of revenue opportunity and therefore growth. It's simplifying the operation, and it's also helping them to arrive at some competitive advantage. So that was a look at service provider adoption. If we think about what's coming down the pipe, what's coming next regarding IPv6 innovation, if I seek to summarize some of the detail on the screen here, SRv6, it's an improvement on segment routing. Importantly, what that's going to mean is it's going to enable service chaining, which is required for 5G. That's already been deployed by service providers in Asia Pacific, Europe and Africa. SRv6 network programming, what that's going to do is going to help service providers provide better SLAs, which is very important in their 5G network slicing offerings. AI is going to tie that all together and improve overall network performance. And really the key theme here is the fact that 5G has the potential to be so complex that it's really important to make the rest of the network as simple as possible. And what we see across all of the innovations here on the screen is that they are all fundamentally designed to simplify transport across the network. And just to wrap up, summing up here, demand is moving to applications like 5G and IoT in particular. Demand is moving to applications that are going to need strong performance. Current solutions simply aren't fit for that particular purpose. So there's a need to invest in infrastructure that allows migration to IPv6. And in order to access those revenue opportunities associated with the high demand applications, in order to mitigate future cost implications, those investments need to support infrastructure that is IPv6 ready. Thank you, Tony.
Thank you, Mark. Really interesting information. Then we'll go to Bukar, CEO SAMENA. Bukar, it's yours now.
Yes, thank you very much, Tony. I'm going to share my screen. Tony, can you see my screen just to make sure?
Yes, it's working well.
All right, thank you very much, Tony. And congratulations for organizing this discussion around a very important subject. Ladies and gentlemen, colleagues, good morning. My name is Bokar Ba. I'm the Chief Executive Officer of SAMENA Telecommunication Council, which is representing globally the operators in the Middle East region and the private sector at large. So it's a pleasure for me to be here today and talk about this most important subject, IPv6, the transition toward it, and it's important to the economic development. Now, when you look at the title of my presentation, I am mentioning the necessity, and I would like through few slides to prove that it is no more a luxury, but a necessity if we want to head toward a sustainable, digital, hyper-connected world. Now, the discussion that we will be having around this concept of necessity in the context of digital development. So we always have to look at where we want to head to digital development. And for that, I would like, through the flow of the presentation, illustrate 4 key dimensions. The first one is, what's the current situation globally and the ICT landscape? Then we will look and head toward what is so-called Agenda 2030, which is the key objective that we want to achieve by 2030. Second dimension, the implication and necessity of digital transformation, once again in the context of 5G era. Third dimension, the significance, basically what does it mean? How quickly are we going to shift? And we have no other choice. It's either IPv6 or IPv6. Fourth dimension, what would be the recommendation? And if we want to keep a low profile, what are the options on the table for private sector, government, and making sure that we are not leaving anyone behind on a sustainable way. So these are the 4 dimensions I would like to cover through this presentation. I apologize. Now, let's look at, we don't have much time, I'll go very quickly on this. For a few minutes, let's keep aside the concept of IPv6 and let's look at where we are today. If you look at on the slide on the top left, 5G. The world is moving into a new digital ecosystem. We call it 5G, but some people who, the debate about 5G, not 5G, let's call it the digital infrastructure. But what is important here is I am not talking or referring to a technology, I'm referring to an ecosystem that has the aim to connect everyone, everything, everywhere. So let's simplify the debate. Now, to get there, we have a number of obstacles that we need to solve. One of them is understanding what 5G is. That's a very big debate, but it's a great impediment. Number two, we have investment issues. Number three, we have use case issues. And number four, policy and regulatory framework. So these are the key four impediments that we have to be able to live in this digital infrastructure. We have, right under the 5G, we have IoT and industrial IoT, and I'm referring to the fourth industrial revolution. So this is going to be a key element for making our digital infrastructure a hyper-connected infrastructure. Of course, when we look at also the consumer or the customer from the private sector point of view, we are all aiming for having a user experience, a digital experience, the enablement of digital services, and we will be witnessing a great increase of social platform. Now, if I go on the right-hand side on the top of my presentation, in the Middle East, let's look at also the regional vision. In the Middle East, most of the government, they have defined their national economic framework led by a digital transformation. And these, they all have made effort at a national level on IPv6 strategies that aim to secure an instant growth and leverage the technology for their economic development. So if you look at, for example, in the UAE, we have Vision 2021, Saudi 2030, and the same for all the other countries. Right underneath, what do we have? These famous colors. We moved from the Millennium Development Goal to the Sustainable Development Goals, and the objective, Agenda 2030, is, if you look at where I have the mouth, 17 goals to transform our world through ICT. So we should be living in a better world by 2030 if we reach those Sustainable Development Goals. Now, I am stopping 1 minute here because as we speak today, we have more than 53% of the world population connected to the internet. And the aim is by 2030 to connect the remaining 47% who today are left behind and not enjoying the beauty of digital development. So these are the different things that we have to keep in mind to be able to integrate the notion of IPv6 and the migration toward that. What's the reality today? If you remember, about 40 years ago, we were communicating, and the way we were communicating is completely different from today. Today we are witnessing a complexity of communication, voice, video, data, machine to machine, artificial intelligence, machine to human, cloud computing. So we are getting more complex communication system. Number two, communication in 2020 today becomes a fundamental pillar to sustainable development. I believe we have all seen what COVID-19 had taught us, and this is an opportunity that we should not waste. We realize the importance of communication. Now, this is the current situation. What's the problem? The problem is we have today 7.7 billion people. Remember earlier I told you that we need to connect the remaining 47%. And if you look at the capabilities of IPv4, we cannot go beyond 4.3 billion addresses. And IPv6, as mentioned in the previous presentation, and right here, we can reach much more bigger numbers. So keep a ratio in mind. For one mobile subscriber, we may have 10 connected devices. So if today we have 4.3 billion people connected, tomorrow with the IoT and industrial IoT, smart cities, we will be having easily 43 billion connected devices. So how are we going to fix it? Hence, the necessity that I was referring to, moving from IPv4 to IPv6. So solution is to use IPv6 with its capabilities. That's number one. Only IPv6, as I mentioned here, can fulfill our dream of having billions of devices connected. I'll go to the next slide before being stopped by Mr. Tony. So therefore, what is important in the era of IPv6 is the enablement of digital services by those who are connecting the people, telecom operators. If today they wanted to provide digital services, it's absolutely important for the enablement to move into IPv6. Number two, in terms of we have lots of cybersecurity issues, and our life will be made easier on a security side because it's a much more secure system using the 128-bit encryption. IPv6 also in terms of maintenance will be much easier than maintaining IP tables as we are doing today on IPv4 environment. And definitely with the increasing number of internet connected devices, we will be able to fix the problem of bottleneck in the network in the era of 5G. So we have higher speed, more bandwidth, and at the same time, more IPv6 addresses. So therefore, implementation is a fundamental enabler and sustainability guarantor of the evolving internet economy. Having understood that, we need to recognize, as mentioned on the top of this presentation, that there are some issues. It's not easy, but those issues could be overcome. Number one, from the private sector perspective, it's important, and this is where the ISPs will be taking us to hyper-connected world. It's very important. I apologize, moving my mouse. Second point, which is important, is the consensus building in terms of approaches, because we are all concerned, not only concerned, it's a collective responsibility. Therefore, we need to work on a consensus basis. There is another point which is important, point number 4. I will not go through all of them. Capacity building at a private sector, intra and inter entities and organization. Point number 5, the collaboration is absolutely important, and congratulations to the UAE and Saudi Arabia who have taken the lead in the Arab region for the migration to IPv6. Number 7, it's an important point, it's costly. And I think we used to leave it aside, but it might be important to have an approach, a fundraising approach for supporting the private sector companies in order to fund their migration toward IPv6. Few key recommendations, and I will conclude there, Tony, and thank you for giving me the time. The same challenges have to be recognized also on the governmental sector. Capacity building is extremely important at every layer in the government. Constant realignment, and that is point number 2, between the technology trend and the national vision. Number 3, government has to take the lead as they did today. Number 5, it's important to provide incentive for the private sector. And number 7, it's important, as we mentioned at the beginning, to map the progress with the achievement and with the SDGs. Therefore, coming back, and as a conclusion, Tony, IPv6 is a fundamental and a necessity to all effort toward creating a sustainable digital society. Thank you very much.
Thank you very much, Bukhar, for highlighting the importance of IPv6-based infrastructures for the improvement of digital economy. Now we'll have next session, but before we start, we have a lot of attendee participants raising their hands, okay? Please, no question now. You have to wait, everyone should wait until we done with the speaker. Then we'll open the floor for the question and for the polling. So please now, we cannot do anything, okay? So now we'll go for our next session, which is about government policies that promote IPv6 industry. We'll start with our first speaker in this session, Dr. Bilal Jamousi, ITU. Bilal, the floor is yours. Dr. Bilal, unmute.
Yes, thank you very much, Tony. I'm sharing my slides. Hopefully you can see them now.
Not yet. Okay, now it's good.
Very good. Yes, so thank you very much. Glad to be among friends and colleagues here in the webinar, and also greetings to all the participants online. Wanted to update you in terms of the work that the ITU is doing with member states on the topic of IPv6. And perhaps I can summarize it in three main areas. The first one is the resolutions we have in the ITU. The Plenipotentiary Conference resolution on IPv6, promoting the deployment and assisting developing countries, WTSA resolution, and the World Telecommunication Development Conference resolutions. So at the highest level, the member states have all put the focus on the deployment of IPv6 and the importance of government role, private sector, and academia in this transition from V4 to V6. One of the main contributions that the ITU is doing in this space is the capacity building. Through our regional offices around the world and our development sector colleagues, there is a lot of capacity building because that's one of the essential components to transition from IPv4 to IPv6. And of course, with the capacity building comes often a request from specific countries to provide assistance in their transition from V4 to V6, technical assistance. Which we do on a regular basis and pretty much in all regions of the world. We have agreements with a number of member states, such as the UAE, in promoting the deployment of IPv6 in the Arab region, something that the Arab Regional Office is working on in Cairo, Egypt. We also have a Center of Excellence in Malaysia with the university there, where we're providing a lot of capacity building. And the numbers of certified engineers on IPv6 is rising. So those are some of the key elements of this work. I mentioned the resolutions just to provide a bit of more focus. The Plenipotentiary Conference resolution on promoting the deployment and adoption of IPv6 and to facilitate the transition from V4 to V6. The WTSA resolution from Hammamet on the Internet Protocol address allocation and facilitating transition and deployment of IPv6. And the same with the development sector resolution 63 on the allocation and facilitating deployment in developing countries. Tony, on a yearly basis, we present a report to Council. This is something that the Secretariat and ITU is required to do per the Plenipotentiary Conference resolution, where we summarize all the activities on IPv6. So it's on the radar of all the sectors in the ITU to make sure that we address the needs of our developing countries on this topic. And of course, we would not be credible if we would not be running IPv6 native in the ITU network. We have been providing native IPv6 since 2012. So we have in-house expertise. Since then, our ITU website is accessible through V4 and V6. The entire ITU delicate Wi-Fi network is IPv6 enabled. We are using the dual stack deployments. We have both V4 and V6 at the same time. And in addition, we have a native IPv6 VLAN that is used for testing purposes. So there is a lot of expertise within the house on the deployment of IPv6, the challenges, the security aspects, and how to really make it viable. Last, I would like to conclude with a recent article in the ITU News. Very recently in May, we were happy to welcome Latif, who is part of our panel today, to provide a number of questions and answers in terms of where we are with the deployment of IPv6, to again put the spotlight on IPv6 for our member states and where we are with the deployment. So with that, thank you very much, Tony, and I'll turn it back over to you.
Thank you, Bilal. Now we'll keep in the same session of government policies, and we'll go to our next speaker, Mohammed Zar'ouni from TRA UAE. Please, Mohammed. Go ahead.
Thank you, Tony. Good morning, distinguished speaker and ladies and gentlemen. If you allow me, I'll share my slides. Can you see my slides? Okay, thank you. Okay, great. I think to start with, I will not re-emphasize on the importance of the IPv6 and the necessity of having IPv6 as a norm or DNA within our internet infrastructure in general, because my previous colleagues, they already shed the light on this one. But let me start by thanking all the effort that have been made for the last 2 decades by all internet communities in general, be it, for example, but not limited, the IETF, the ITU, and the IPv6 forums and other great initiatives and great efforts that have been made to make sure that their effort came into the reality, and we started seeing the benefit of having an IPv6 in all nations, in all governments, in all the private sector. So this is just a pictorial representation of how IPv6 started and where we are actually heading, and the tree is growing further and further as we go. Just to give you an important milestone that the UAE went through for the sake of understanding what we've done. And our journey with IPv6 started in 2011. And I remember I was the CTO of the .ae domain registry at that time, and we participated in IPv6 Day. It was in June 2011. And we were the first website which talks IPv6 in June 2011. So we're very honored to be part of this achievement. Of course, there were subsequent progress when it comes to IPv6. We started liaising with the RIPE NCC to conduct a couple of training in 2011 and 2012. And then in 2012, we have put our effort in chairing an ITU IPv6 working groups to emphasize on the importance of a government as a shared responsibility with the private sectors to encourage the adoption of IPv6 and ensuring the engagement of the government when it comes to the policy development of IPv6 at early stage. In 2014, we delivered the roadshow with our partners to further train and do a further capacity building. In 2015, the Telecommunication Regulatory Authority drafted a strategy that stimulates the adoption and the transition from IPv4 and IPv6. We conducted a readiness survey across multiple ecosystems and multiple stakeholders, be it the government, private sectors, telecom operator, to see the readiness and to assess what needs to be done. In 2017, we signed an MOU with RIPE NCC, and we participated and hosted the IPv6 government roundtable. As we speak, we continue supporting the adoption of IPv6, giving the importance of such a component within the internet infrastructure and ecosystem. So if I may summarize any government role in IPv6, what we believe that the government can contribute into 3 main pillars. One of them, of course, the encouraging the adoption, promoting the use of IPv6, and the most important thing, as I see it in this region, is to help as much as we can to increase the awareness and build the capability within the technical people who are working in this field. As a result of our effort, we believe that the UAE, as mentioned by my previous colleagues, that position itself as a leader in IPv6 adoption. As Akamai says, we are around 30% IPv6 traffic is originating or coming from UAE out of the total number of traffic. As per Google, we're around 26.7%, and we keep monitoring our progress and being ambitious towards increasing the percentage as we go. What the efforts that have been made in general, as I mentioned, we started with a national strategy that shed the light on the importance of IPv6 and came up with a couple of initiatives to help all the stakeholders towards the migration and adoption of IPv6. There were a couple of strategies and policies that been published that might not talk about IPv6 per se, but definitely help into speeding up and accelerating the adoption of IPv6, especially the IoT policies and AI strategy. We will continue contributing in international forums in different dialogue on the best policies towards IPv6 adoption. We might use our regulatory policies to help and assist the situation, monitor the progress of IPv6 adoption across all the sectors. And this is in general what we believe that the role of the UAE telecommunication regulatory in fostering the use of IPv6 and adoption of IPv6. Our national strategies consist of 4 main pillars. I will not go into the details, but as you can see in the presentation, the awareness is very important. The government and management at early stages, I remember that we started even encouraging procurement agencies and procurement department within the government to ensure that all their procurement of devices and softwares are actually compatible with IPv6. And I believe that was in an early stages. Now it became as a norm. Many of, I would say, most of the devices nowadays became IPv6 by design compatible, but it was very important at early stage also to emphasize on this one. Infrastructure as a services is very important to ensure that it is a seamless transition to the end user. End user shouldn't be impacted negatively with the adoption of or transition to IPv6. So that pillar was very important also, especially for the ISPs. Policies of, and regulation in case that they need to be having any policies. I mean, the national IP strategy shed the light on this one. When it comes to our effort with other agencies, these pictures might show the importance of collaboration on the national, regional, and international level. RIPE NCC would like to thank them for their continuous support when it comes to IPv6 capacity building. Of course, IQ have joined us also with CODI and other venues to help also to increase the awareness of IPv6. So we'd like to thank them on this one. We hosted MENOC 15 workshop, and the workshop was talking specifically on the IPv6 adoption in the region, so it was very important. One of the things that also we've started conducting the Train the Trainer program, because what we believe is that we need an ambassadors to help spreading the culture of IPv6 readiness and adoption. So we conducted a couple of Train the Trainer sessions within the TRA with the support of our partners. These slides would focus on the readiness and the availability of IPv6. So if we are talking on the left side of it, I'll not go too much technical, but the current .ae registry CCTLD DNS currently supporting IPv6. So all of our main DNS servers, which is serving the .ae country code top level domain, do support dual stack, which is IPv4 and IPv6, and along with our secondaries partners like PCH and APNAC. When it comes to the operators, we continuously cooperating with them towards the adoption of IPv6. For example, in my house, my internet connection is IPv6, so this is a great achievement, and I would like to see this one is happening across the UAE. Just to, I have 2 more slides to finish. What we thought of when we started the strategy is to help any stakeholders to go through a couple of phases towards full IPv6 adoption. This plan started with initiation and planning, assessment, the requirement, going through the design, implementation, monitoring, and assessment. And I believe this plan was kind of a valid long time and is still valid. However, many of the organizations are already in the implementation and monitoring stage. This is what we've noticed in general. We will continue supporting the capacity building and we put it as a part of our TRA Virtual Academy. To conclude with the last presentation, as you know that the government have reformed recently in the UAE, and part of it was emphasis on using a technology as a main driver for the digital economy with the adoption of autonomous cars, 5Gs, IoTs, Internet of Everything. I believe that the IPv6 will become a kind of a DNA of any infrastructure development and enhancement. With that, I would like to thank you, Tony, for giving me this opportunity to talk about the UAE government effort into IPv6. Thank you.
Thank you, Muhammad, for this really interesting government policy toward IPv6. And I will check today if our office using IPv6 here in Media City, because I'm jealous now. You make me jealous. Okay, now we will go to our next speaker, which is, he's the founder of IPv6 Forum. So I cannot talk more. It's for you, Latif, please. Latif.
Can you see my slides now?
No, now it's starting, is uploading now. Yes, very good.
Okay. It's a bit slow.
No, it's fine, but you skip one. I guess you have to go back to the first one. Yes.
Right.
Thank you.
First of all, thank you very much, Tony, for organizing this and inviting such an excellent panel. As a matter of fact, they have stolen most of my tender from my slides. So I'll be more duplicating what they're saying. I'll try maybe to say something else. So first of all, we have started the IPv6 Forum back in '99 when IPv6 as RFC 2460 was basically released in December '98. And at the same time, 3GPP was started and we were looking for a killer application for IPv6. And obviously 3G was there. So it took us about 1 year to convince 3GPP to adopt IPv6, which they did in May 10, 2000, while they wanted to adopt at the beginning the WAP protocol, wireless access protocol, which have most probably, which would have most probably thrown 3G into a different direction. So I'm glad that they have adopted IPv6 at the beginning. But then the ISPs decided that they didn't know how to implement IPv6, so they knew about how to do that with IPv4 and NAT. And that's why 3G started with IPv4 and NAT. But at least we got the internet on the wireless devices, which most probably, if we didn't do that, the current wave of wireless applications on smartphones and so on would not have existed, and probably Apple would not have invented the iPhone. So you have to be quite early at that stage in order to do those magical changes. And we have still many to come. And I think with the COVID, as my previous speaker said, there will be shifts in adopting digital technologies in many things, but we have certain challenges there. How to get 5G and cloud also working, how to get autonomous driving and industrial automation to be done with certain KPIs, as well how to swiftly provision new services instead of waiting for a couple of months, if not years. How can you do that swiftly, let's say within a couple of hours? So when you look at the address space, we knew a long time ago that V4 was not for the entire planet, as 75% of the IPv4 address space was allocated to the US anyway. So the rest of the world had to live with 25%. And we still have that same problem there. And again, with IPv6, we are also creating a new digital gap because only the top companies are doing IPv6 and the rest of the world it still has to be pushed. So I think the previous speakers are shouting for full adoption by the new technologies for the entire planet. And we have plenty of address space. And not only that, we have new functionalities that are coming up. So I would highly recommend, if you can look at the paper we are going to publish by the end of this month, where we are summarizing the various efforts from a certain number of key players in promoting the right predicaments and the functionalities for the IPv6 adoption. And obviously there are some new things where we are pushing for IPv6 only promotion because so far the transition has been very sloppy, as well as the clear end-to-end model was not properly specified. So we have been adopting IPv6 like IPv4 just for connectivity, although V6 with its end-to-end model can offer magic technologies, some of them that are going to be deployed down the road to support the ISP deployment in various areas. So it's really from the current models that we have found out that it can reduce CapEx and OpEx, as well as it will accelerate the connectivity. As a matter of fact, in some cases, we see something like 40 to 60% higher speed using IPv6. And the deployment is not that expensive, as mentioned earlier on. It is a lot cheaper to do. But the issue is that by doing dual stack, you have the fallback to IPv4 always, which is not very good for the internet because you have to do the fallback on IPv6. That's why the adoption of IPv6 only is fundamental. So we have to tweak all of the things that we have tweaked in IPv4. They should be done in IPv6. And that will allow us to move into the next use of the functionality that are going to be adopted in the world, such as how can we use the end-to-end model by using new functionalities like source routing, using V6. So you can skip, good technologies that have done a very good job in the past, like MPLS. You can use directly end-to-end communication between the devices, as well as add new functions for operations and management, like combining IPv6 with artificial intelligence, as well as the many functions that are going to come up down the road by using like BEER6 for multicasting, which we are not yet using at all. And IPv6 is a multicast protocol by design. Since I don't have much time, so just an example of how SRv6 being deployed so far in some countries, even in my country, in Luxembourg, our local operator who has deployed IPv6 as the first one in the world is now testing SRv6 to replace MPLS, as well as new functions combining artificial intelligence in order to reduce the nightmare of deployment of the new networks. Especially now, we have to be very agile, to get the new verticals that are coming up, like energy efficiency networks or autonomous driving, as well as healthcare and those kind of applications that are dearly needed these days. And as I mentioned earlier on, we have a lot of countries that are doing their best, to get V6 deployed. And I can see on the list some of the famous people. I just looked at the name of Halima Katir from the Ministry of Industry and Economy in Morocco. She's doing exactly the same work that the Saudis and the UAEs are doing in the region. And as a matter of fact, we have even an IPv6 council in Yemen, and the prime operator there has deployed IPv6 for about the last 6 to 7 years. They have about 2,000 users, at least, from in terms of capacity building. That is really fundamental. And we have the same council in the other countries like Oman, Qatar, and Kuwait, Jordan, even in Palestine, Israel, as well as Egypt for a long time. As a matter of fact, Egypt was one of the first ones to adopt IPv6 from the Ministry of Communication at that time was our famous minister who has passed away, unfortunately. So these efforts are fundamental, to get everyone to empower people in their own country to do their own work, to get the work to be done and not depend on external help and support, although it's needed at the beginning. But I think the community has to create its own dynamic. As Mohammed from TI has mentioned, you have to have your own expert in your own country. So we are starting a new ETSI IPv6 ISG, and would like to invite all of you that are on the call, to join us, to create a new momentum, to get IPv6 to be done, not only by the famous big countries and big organizations. We have to get everyone to use IPv6, and most probably by 2025, think about kicking out IPv4 from the internet and reduce the internet to one single internet, not to have an IPv4 internet and IPv6 internet, which is too expensive and very much into the detriment of new technologies. So I hope I have kept my 10 minutes.
Okay, thank you very much. But I have one request, a lot of requests, in fact, from our participants that you're not using full screen and your presentation, they cannot read it very well. So to all participants who send me a lot of questions, now we have session for Q&A. And President Latif was asked, so you can send your question to him, okay? Because I answer you, all of you, that you can change the grid view from your own laptop. So you can see the presentation at full screen and the speaker small window, okay? Please practice this and believe me, you can see everything. Okay.
Very good point. As a matter of fact, I have a 90-inch screen, so it's huge.
No, even I'm using 14-inch, but it's the setting of Zoom how you can see the screen of the others. You can make it all for the slide. It's just setting. People maybe still new on using this, but just you can address your question later. And thank you again, Latif. Now we'll start to our new session, Standardization Interoperability Progress. We'll have two speakers, Robin Lee and Carsten Rosenhovel. We'll start by Robin now. Are you ready, Robin?
Yes, can you hear me?
Okay, you can go ahead. You have to stop screen, your share screen, Latif, please.
Okay.
Latif, please stop your share screen.
I can do it himself.
Okay, please.
You said someone else is share the screen. I cannot share.
He's still sharing the screen. Okay, now he's out. Okay, you can share now.
Okay.
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 Very good. Okay. Okay.
It's okay.
Now it's good. Yes, you can go ahead, please.
Okay. Okay. Good morning, everyone. Okay, and also thanks for Tony to provide the chance for me to present the IPv6 plus standardization work and its progress. This is Zhenbin. Yeah. So Latif had mentioned the IPv6 plus. I think this is a new era of IP networks for 5G and the cloud. So I think that in the past 20 years, so that's the IP already successed in the internet through the IPv4 and through the MPRs. So that's either achieved the all IP and it too used for the metro network and used for the mobile transport network and also the IP backbone network for the multiple services. But now I think for the 5G and the cloud, so it provide a great chance for the deployment and the development of IPv6. Because we know in the past 20 years, the address space is not enough as a requirement of the IPv6. But now, as the development of the cloud and the 5G, so there's a lot of new chance for the IPv6 innovation. So here I summarize it as the 3 key points. The first one, because of the development of the cloud, so the connectivity becomes more flexible. So the connectivity need to depend on the natural IP reachability, so it can set up the connectivity easily. So I think the IPv6 is easier than MPLS to achieve this goal. The second one, because of the new applications and services such as network slicing and deterministic networking is proposed for the 5G. It needs more encapsulation information in the forwarding plane. IPv6, it has the extension header to incorporate the new innovation, but it's very hard to be satisfied by the IPv4 and MPLS forwarding plane. The last one, we think that as the development of the cloud, and it's need the synergy between the network and the cloud. So yes, it's necessary to combine the application information with the network information, so that it can achieve the goal of the fine granular the applications, and also it can improve the value of the networking. So we think the IPv6 is the natural media to satisfy the requirement to combine the application and the networking. Okay, I think this is a great chance for the IPv6 in the 5G and the cloud. So here is just a brief glance at the IPv6, because we know that the SRv6 has achieved a lot of development in the past years. So that is provide the network programming capability. And also we know that the IPv6 has other extension header, such as the hop by hop and the destination option header. It can encapsulate more information for the new services, satisfy the requirements. So that's we think the IPv6 extension header and the SRv6 can release the network programming capabilities for satisfying the new service requirements. So we think that is besides the requirement of the address space. So we think the network programming capability based on the IPv6 is another important drive for the development of the IPv6. Okay, because now that there's a lot of new innovation based on the IPv6, in order to guide the industry development smooth and introduce the new innovation step by step, we that is provide this is a proposal of the plan of the IPv6 innovation work. And also here is the suggestion. The first phase we think that's important is the IPv6, the basic capability. That means the VPN, traffic engineering, and the fast reroute. Because this is the most important features has achieved a success in the MPLS era. So the SRv6 should inherit this advantage firstly. Second phase is we think some of these the new services for the 5G cloud. So here we think the most important one, including the network slicing, in situ telemetry, and also this the BRv6 for the new multicast services. So besides this, the important new services, we also have some of these the services such as the OEM, and also the path segment for the performance measurement, and also the deterministic network, and also the SFC SD1. And also now there is a lot of the discussion about the SRv6 compression. So that means for the SRv6 be used in a wide range. So that is the as the increase of the header size, there should be the solutions to compress the SRv6 header. to satisfy the requirement to be used in a wide range. And the last, we think the third phase, that's the APN6, means the application-aware networking. We think this new architecture to combine with the application information with the networking information. So that is a new phases. So now that is also some work is being done. Okay, so here this is the layout of the IPv6 plus standardization work, which has been done in the IETF. So we can see this is phase 1. So the SRv6, the basic capabilities. So the first one, so we can see the SRv6 forwarding plane, the SRH. It has become the formal RFC. That means the formal standard in the IETF. In fact, this is also the first RFC of the SRv6. This is a strong, this is an important milestone for the development of the SRv6. Besides the forwarding plane, we also can say that the protocol extension, which means that the control plane, that is all the draft has been adopted by the working group. So that means that this draft has been mature and enter into in the new phase of the standardization. And besides this one, now that's the young model of the SRv6 is being adopted by the working group. So this will facilitate the interworking to configuration SRv6. For the second phase of the IPv6 plus standardization work, we can see that's the VPN plus for the network slicing. There's already the working group draft for the framework. And also now that's the data plane for the network slaying, for the network slicing, also being adopted by the working group. And also the next one says is the in situ telemetry, and also the SAMENA, the framework and the forwarding plane has been adopted by the working group. And the third important one, that is the BRV6 for the multicast. The requirement has been adopted. So we think that this important functionality for the 5G and the cloud has been accepted by the industry. But now we think that is more standardization work in the control plane will move forward. And now, besides this, the three important functionalities. So now that's the OEM, path segment, and also the data net. And also that's the service chaining, SD1, and also the SRv6 compression standardization work is also being done. We think that also will be helpful for the development of the IPv6. And the last one, I think this is the third phase, the APN6 network. So this has been proposed several drafts, including the problem statement, use cases framework, and also the encapsulation in the IPv6 forwarding plane. So now that we already hold a APN6 side meeting in the IETF, and also that is we collect that is 10 more these operators and vendors to agree on this value of this work. Now that the work is being smoothly moved forward. So this is just is a glance on this is a layout of the IPv6 plus standardization work being done the IETF. If you want to understand the details, please visit IETF, this website. And here we also have provided this IPv6 plus net, so that here you can understand more that all about this the whole picture of this innovation work. Okay, that's for my. Okay, thanks, Donnie. Okay.
Thank you. Sorry, you're over time. Okay, sorry. It's very interesting, details and technical, but still, you know, we still have also to hear from Carson Rosenhovel. Carson, are you ready, please, for your presentation?
Sure, anytime.
Very good. Okay, can you stop sharing screen, Robin, please?
Okay.
Okay. Carson, please, it's yours.
Thank you. I'm getting ready to share. Just give me a second.
No problem. Just I will say something because I'm still receiving Q&A raising hand from the participant. Please, we will have Q&A after Carlson now if Majid didn't join from Du. Okay, so please bear with me. We will answer all your questions. Okay, just when we finish. Please go ahead, Carson, now.
Yeah, thanks very much. And I think it's, I'm just going to wrap up the presentations with a factual check from what's actually happening out there. So EANTC is an independent test lab. We test innovative protocols. As such, we have tested IPv6 for many years, for over a decade. And now we're moving more towards the advanced aspects of network transport and services around IPv6. So obviously the data plane was first. And
sorry to just Carson, because some people didn't get you, didn't hear you. They said the voice is low. So if you can raise your voice little, please.
Okay, sorry about that.
Thank you.
I hope it's becoming better.
Yeah, it's better. For me, it's good, but or for all the participants, because I received this comment.
Okay,
thank you.
No worries. Good. So we focused on testing IPv6 VPN services, mobile services, of course. IPv6 has been enabled in mobile networks for a long time, but there are still areas around that require some innovation. For example, VoLTE, as was mentioned. And now, today, I would like to speak about a couple of interoperability tests and functional tests that we have conducted with a number of vendors earlier this year. They focus on aspects that Robin has introduced of SRv6, segment routing over IPv6, and also network management of IPv6 networks. Because in a more complex world with advanced IPv6-based services, of course, the network management also becomes a little bit more complex. And finally, I think what should not be overlooked, but it's more a footnote in today's presentation, are the security aspects, because IPv6 also opens new attack vectors, and that's something that we also analyze at EANTC, but it would be too much details for today.
Closer to the micro, please, again. We have a lot of requests. Sorry, Carson.
Sorry.
Close to the micro, please.
I think I'll change to my built-in microphone.
Much better now. You can hear the difference. Okay, go ahead. You can even repeat the little sentence.
Sorry about that. Okay. So in any case, I'd like to introduce two projects that we have conducted this year. One of them being an interoperability event that we stage every year at EANTC. This time together with more than 15 participating vendors. It was a little more difficult during the Corona times, but we have moved it to almost full virtual remote testing so far. So we managed to get it done. And we had more than 100 attendees in total participating from these 15 companies, more than 500 test executions. So it's a fairly massive interoperability event. I believe it's the biggest one in SDN in the world. So as part of this, we have also looked at IPv6 technology, specifically the segment routing v6. And if you can take a glance at the topology, here you can see with this red square around, this is the SRv6 topology. And what's quite interesting here is it's not the only one. So I think the time when 100% of the world will be IPv6 only will still take a little while, but that's not a problem because SRv6 and IPv6 can interwork well with even legacy parts of the network, like the yellow part in this diagram, which was MPLS based, and the dark blue part, which was segment routing based on IPv4 transport. So SRv6 has found its place in the world, or is finding it. Here is a snip of this part of the topology diagram. And you can see that there were quite a number of vendors supporting this SRv6 transport already. So Cisco, Juniper, Nokia, Huawei, and Arcus, which is a data center vendor. So this is a disruptive path, innovation path, and it requires a new data plane. So that's the normal challenge with IPv6, right? You have some disruption. But in this way, we also gain opportunities, we gain features that were not possible with the traditional legacy IPv4-based and MPLS-based transport. And what's quite most important here are the resiliency topics, as Robin has explained from the standardization point of view. at EANTC, we're validating these from the actual implementation point of view to make sure that the industry actually follows through with these developments. So we look just very, very quickly at two scenarios that we conducted. On the left-hand side, you see a typical test scenario for a topology independent loop-free alternate, which is the resiliency and failover solution. And the failure of link here, the one that's marked with a red cross, only takes 2 milliseconds to recover, even in a multi-vendor environment. So typically, of course, these networks work well in single vendor proprietary environments in the past, but it's the strength of the standardization and the multi-vendor solutions that really make a technology fly. So even on the transport and services side, IPv6 Plus is getting ready for the production. On the right-hand side, that's another very important aspect. So for many years since I started my career, people have talked about quality of service on the internet and over IP services. And typically this hasn't happened because you just throw more bandwidth at the problem and it solves itself. But now with 5G and especially the slicing and the diverse types of services that are being introduced in 5G, traffic engineering, like QoS-based, constraint-based routing in the network becomes even more important. And that's another point where SRv6 has a very good advantage because of the features of the technology. So in this example test case here on the right-hand side diagram, we tested path selection based on segment IDs, based on specific directions between multiple vendors, but it's also possible to use SRv6 based on very advanced selection criteria like latency, like bandwidth balancing and other aspects. So in a multi-vendor environment, again, on the right-hand side, you see multiple vendors here, 4 if I count correctly, plus the test tool vendor Keysight. In a multi-vendor environment, these technologies are working well and the standardization has succeeded, I would say. Now, another engagement that we conducted recently is an independent individual test of Huawei's intelligent IP network solution. We tested this in a Huawei lab in China, and we focused mostly the NetEngine 8000 family of routers. We built a rather complex test scenario to really replicate realistic network deployments with the 12 routers you can see in the bottom right. And we conducted a large number of tests, functional tests, mostly focusing on SRv6 and IPv6. These included obviously the transport, the throughput performance, the features and so on, but also provisioning and monitoring, which is quite important, I think. Now, for the transport services that we verified that it's possible to build a fully serviceable network with IPv6 Plus for the layer 2 VPN, layer 3 VPN services. So this is typical enterprise VPN customer environment, also with layer 2 point-to-point services. And we tested also that it's possible to troubleshoot these networks because, again, a consequence of increasing complexity in transport networks is that troubleshooting these networks becomes more cumbersome and more challenging. So it's important that the troubleshooting tools are growing in the same way with the complexity of the network growing. This is an area where the IETF, the Internet Standards Group, has also conducted a lot of work. And again, in the bottom right diagram, we looked at the resiliency and we saw that it's possible, even in very complex scenarios, to provide failover usually within less than 3 milliseconds. In some cases with less than 11 milliseconds with another type of technology. But in the TILFA scenario, 3 milliseconds is really awesome. The gold standard for failover in carrier networks used to be 50 milliseconds for a long time. And I think with SRv6 and IPv6 Plus, we're even improving this by a factor of 15 and more. So these test cases were very successful. My last content slide here is about the management. I think the management, of course, is kind of separate. And network management, OSS solutions have always been operated at service providers. but in most cases, it was sufficient to just configure routers in some way, mostly using a command line interface. Now, with the advent of the 5G slicing, the way more complex services and the complexity built in by IPv6+, it's very important to move to graphical user interface-based network management solutions that really are displaying the complexity in an appropriate way. So we tested here a management solution from Huawei, but we've also tested other management solutions from other vendors likewise, and they're all going into this direction to really show the provisioning, ease the provisioning, and show the status of the network, including performance monitoring and alarm management from a high-level service perspective. And this tool here that we tested in January this year allows the complete configuration of these SRv6 tunnels, of all of the features and the services through the controller. And it includes also these advanced constraint-based policies, allowing the operator to set up advanced policies for link latency, for bandwidth balancing, for cost of certain links in the network without getting into the details of command line interface configuration. And what's most important, of course, all networks are running and changing their situation. So maybe there is a link failure at some time. So it's important that networks also re-optimize automatically. I could speak another hour about re-optimization. I want to skip that for now. There's of course much more information available at our website at EANTC.de, where we publish all the details of our reports free of charge. So re-optimization is a very important part. If a base station fails, if a part of the backhaul network fails in a 5G scenario, that's all possible and happening on a daily basis. And still service level agreements need to be maintained. That's a natural truth for all types of networks, but I think with 5G, with IPv6+, we are getting to higher requirements, and we're getting to a better way of implementing these requirements and meeting the demand. Now, to summarize, from my point of view, currently today, the most important aspect of IPv6+ is this combination of the IPv6 data plane with segment routing v6 transport and with management functions. That's where we continue to engage in multi-vendor and single vendor public tests, and also in private tests that we conduct with our service provider customers. We have evaluated advanced functional and multi-vendor interoperability scenarios so far. Of course, the provisioning I talked about. From my point of view, the SRv6 implementations are now becoming ready for production use in 2020. The one interesting challenge that I see ahead of us is the performance and scalability evaluation. Naturally, SRv6 behaves differently than other MPLS-based technologies, and it's important as we are ramping up the deployment of IPv6 and SRv6 throughout the internet and throughout service provider networks to really validate the performance and scalability of these implementations as well.
Thank you, Carson. Thank you very much. And now we start receiving questions from the audience, but just for the audience, please, it's better if you can address to whom is you address your questions. And Mark Bokar, please, if you will be with us now, because we'll start the question, the Q&A. Okay, you can see first question, okay. You can read it. What the best approach for early adopters IPv6 in enterprise and service providers network place? Okay, who will take this question? You can start now. You can read the in the Q&A, please. We have already many questions now. So there is last question for Mark. The others are open. Who would like to take the first question?
Yeah, I'll take the first one since nobody is.
Okay. Please look.
So basically, the best thing to do is to look for best practices of other companies, because that's the internet model. So you have to learn from the success and the mistakes of the others. So for the enterprise, and that's a very important topic. So we have the top technology companies like Google, Microsoft, Facebook, and LinkedIn, YouTube, and so on. They're adopting IPv6 only in-house, and then using transition mechanism to connect to v4 world. So they're using things like force, 464 translation, so XLAT. So I would look at on the internet and Google how they have adopted it. Now, with the question on the enterprise, because the majority have moved to the cloud use. And unfortunately, cloud services are kind of monopolized by Amazon. And Amazon has not yet moved to IPv6. And they have also a stack, their own stack, which is proprietary, which creates another problem, which is data sovereignty. So when you have a proprietary stack based in the US, you have obviously possibility backdoors to NSA in the United States. So anyone that's connected to Amazon as an enterprise is basically has a risk that its data is used by NSA. So I would not really favor the use of Amazon in view of data sovereignty in each country. So currently in Europe, we have an initiative called Gaia X, to have a European-based cloud computing services. So I talked to the lady running it out of Paris, but unfortunately they are not using the OpenStack. So normally we are promoting the OpenStack with IPv6 so that we have a worldwide stack that we can look into. So all researchers, especially in security and cybersecurity, to look at the stack and see what kind of backdoors exist in each country. So here we have an issue, to get basically the enterprise to adopt cloud computing using IPv6 and using an OpenStack, OpenStack for that. That's why the enterprise are behind currently. And you can see that from who is buying the IPv4 addresses today. It's basically the cloud computing companies. So primarily Amazon and Microsoft. So blocking the enterprise to move to IPv6. But top companies are already doing that. As to the service providers, so you have to look at the MNOs, so in this case, mobile operators. And in India, we have the best case, Reliance Jio. Their best practices published, you can have a look at it. So since they cannot get IPv4 address space from APNIC in Asia, so they have deployed 4G with IPv6 directly, making India #1 IPv6 nation in the world with 360 million users of IPv6 without even knowing it, which is the beauty of the protocol with IPv4 and IPv6. So you can Google the best practices for the top enterprise companies and for most of the service providers on the internet.
Thank you very much, Latif. We'll go to the next question. How we can choose the best and easiest IPv6 transition method for the enterprise and service provider network? I will give this question to Robin, please. Robin, can you take this question?
Okay, I wanted to take this question. Okay.
No choice.
I think, yeah. Okay, yeah. I think that's for the service provider network, as seen is a big scope because that's for the service provider, they have the metro network, mobile network, or the backbone network. But in general, I think the SRv6 is a good chance for the service provider to introduce the SRv6. And the transition we suggest is like this one, because the first one, we enable the IPv6, the reachability in the existing network based on besides the IPv4 reachability. After we get the IPv6 reachability, so that's based on this, the infrastructure, we can deploy the SRv6, the VPN, because we know the VPN is an important service for we can get the revenue, more revenue for the operators. And also this is easy to be deployed based on the SRv6. Then after that, we can introduce the SRv6 traffic engineering. This is the advanced services for the SLA guarantee. So we think this is my suggestion on the service provider networking. And for the enterprise, I think now that's that is the most used VXLAN. So I think now the SRv6 is used for the enterprise may need the ecosystem. So I think that is now, I think that if you want to introduce this, the SRv6, maybe think firstly the VXLAN based on the IPv6. Then maybe later, if that's the SRv6 ecosystem for the enterprise is mature, you can also think about a transition to the SRv6. Okay. Yeah.
Thank you, Robin. Now we'll go for a question. I will jump some questions now because, okay, we have a question. I'm not sure who can answer it. When the SRv6 standards will be fully ready to support all features being supported? I'm not sure who can take this question because it's SRv,
okay. Not okay.
I
think that,
okay.
Yeah, I can take. The first one, I think that is there's no the SRv4 because now that is the only has the SRMPRs. If I mentioned that's the that's the IETF, they are the IB. That's they also use a proper statement several years ago. They recommend that's the new solutions is being promoted based on the IPv6 forwarding plane instead of the IPv4. So I think this is just some the statement means that we will almost we stop the development of the IPv4. That means in the forwarding plane. So that is why I explained in my first slides, because now there's the 5G and the cloud need more the new application and need a new encapsulation in the forwarding plane, but there's no chance for the IPv4. And also that is for the MPRs even also has this challenge to satisfy this requirement. So we think that is a big chance for the IPv6. So from my point of view, I think this cannot be satisfied by the IPv4, or that means that's SRv4. Yeah.
Thank you, Robin. Just reminder for all the participants that we have poll. Okay, we'll open the poll soon. We can maybe reduce the questions, maybe because to keep on time. But now, before how the operator enhance return on the investment from IPv6? Who will take this?
Tony Bokar, I will take this question. If you allow me, the migration IPv4 to IPv6 should not be seen as a return of investment transaction. It has to be seen as a optimization of the OPEX, because in terms of maintenance, in terms of support, when we look at the cost of security and maintaining the flow of the traffic, it has to be seen as something that is going to ease the operating and maintenance cost. So definitely operators will have to go through some optimization calculation, but in terms of OPEX, it will be much easier and less costly to maintain tables using IPv6 than having dual table and conversion between IPv4 and IPv6. I hope it answered the question.
Thank you, Bokar. We'll go to another questions. What the difference between IPv6 and IPv6 Plus? Question is to Latif.
Yeah, it's very simple. So as I mentioned earlier on, we have been using IPv6 in a similar way than IPv4, and we have not understood that IPv6 has restored the end-to-end model, which means that I have routable IP addresses from source to destination, and I have plenty of that. I'll be able to do end-to-end services as compared to IPv4. So for instance, SRv4 cannot work because you don't have routable IPv4 addresses to give to every service. So the fact that the end-to-end model has been basically broken by the interaction of NAT, in this case, not giving you routable IPv4 addresses. So you can only do it when you have, let's say, a clear source to destination addresses and routable. That's the main difference.
Thank you, Latif. Now I have a question to Muhammad Zar'ouni. Muhammad, have you seen any challenges with end user devices in home network like LAN switches, access points, which are generally outside of your view of service providers?
Thank you. I think this question, maybe the service provider, the one who might be able to answer it, but as of now, we haven't received any complaints from consumers with that regards. And in case that there is such complaints, we're definitely here to support and liaise with the service provider for that.
Thank you. And I have another question for you, Muhammad, in fact.
Sure.
What is the UAE strategy for next plan to promote IPv6 deployment?
Thank you, Orleth Finn. I think this is a very important question. And there are actually 2 points which are very important, and we will continue investing in. One of them is the capacity building, as we believe that, I mean, the human factor of it, despite the importance of the technology, human should be equipped with all knowledge and skills to deal with IPv6 addressing, routing, and enablement and adoption and migration. So with the cooperation and coordination with the different partners, such as ITU or IPNCC and other partners, we definitely continue supporting that point. The other point, which is very important, and if you look at one of the slides which I present, that the RIPE itself, IPNCC itself, came up with a model called ripeness. The ripeness identified those who were actually started using IPv6 and categorize them into 4 different stars. So as soon as you've been allocated an IPv6 from your regional internet registries, you'll be assigned, let's say, for example, star 1. And as you keep like adopting and enabling IPv6 in your network infrastructure and going through all the checklists, your stars get raised. So if you look at the UAE and segregate the LIR, local internet registries, into 2 main segments, we don't have an issue with the ISPs because they have the capability, they have the know-how, and they are maturing and progressing when it comes to implementation. So talking with Salah. What would be the next stage is to look at other local internet registries who've been assigned IPv6, and we'll try to find out what obstacles, what challenges that they are facing and how the government can help them to go and become 4-star champion into IPv6 adoption in general. We have around 122 LIRs in the country. I would say maybe a good number of them need some sort of liaison and support with regards to this.
Thank you, Muhammad. Thank you very much. Now we have a question to Mark. What is the advantage of IPv6 over IPv4 in security terms? Please, Mark.
I guess the headline thing to say is the fact that security is built into IPv6 at source. It's a protocol that is more built and designed with security in mind. If we think that IPsec is built into the IPv6 protocol, for instance, and IPv6 is designed for end-to-end encryption. So in theory, widespread adoption of IPv6 diminishes the risk of attack. I think the one human element, if you like, that we need to include in the conversation around security is, skills and training, and making sure that engineers in particular have the necessary proper training, in the new protocols so that they're able to, audit and update security devices, and they're able to manage, the protocol more securely. So, IPv6 is designed, with that security in mind, but it also requires a skills training program to ensure that it's implemented, managed, and audited properly.
Can I add something to that?
Yes, you can. You can answer.
So basically,
we're taking last question. One more question, the last one. So please go ahead, Latif.
Yeah. So basically, IPsec was designed for IPv6, and then retrofitted to IPv4. But for that, you need to have routable IPv4 addresses. So it's basically a kind of luxury only to those companies that have routable IPv4 addresses. So the majority of ISPs and corporate companies, they use IPsec within their own network in order to secure their data and data centers and so on. But the last mile is basically not secure. So this is where the chance of using IPv6 and IPsec, but then it would be a policy issue whether you're allowed to use it for your services unless you're a company. So for end users, it's still not possible from a policy point of view. So we're using, simpler security things to the end user like TLS and the likes. But basically, in order to do worldwide IPsec deployments, this is possible in IPv6 with IPv6 and IPsec, which is a fundamental thing for the companies that have worldwide access, or for countries that have, for instance, their embassies around the world. They can use IPsec using IPv6 and basically secure their networks around the world. This is going to be very important down the road.
Thank you very much. We'll go to our last, we have more questions. Okay, please, no more questions. First question is for Carson. Carson, you can take it. Latency throughout is a major focus in area where we have looked or conducted standard KPI for SRv6 and IPv6. Please, Carson, can you take this? It's for you anyway.
Well, thanks. It's, latency and throughput are performance KPIs that are always developing over time of the technology introduction, right? And in IPv6 in the beginning, throughput was a major concern because the chipsets didn't handle it. Now, meanwhile, it's, I would say, almost legacy, right? So almost all equipment handles IPv6 in the hardware as it does handle IPv4. For SRv6, we're a little earlier in the development cycle. So that means that router vendors are just now implementing SRv6, and they need to bring their firmware microcode hardware up to speed. So we do see some challenges in the SRv6 throughput. I don't have any publishable figures here, but I think we're working with a couple of vendors to help them improve their performance numbers. But that's just normal because it's a more complex, more advanced technology, and obviously it has more challenges in performance.
Thank you. Now we'll go to the question to Robin. Any guideline for the date checklist for the assessment and evaluation of existing network environment for IPv6 enablement? Please, Robin.
Okay. I think that we propose this the one draft. That means the SRv6 deployment consideration. I think that's there's some the guidance for the deployment of the SRv6. You can refer to that draft. We tried to propose this more information through this draft, and also we try to provide more public information about these things through the IPv6 Plus website. Okay.
Thank you. We still have one question. They don't address to anyone. Okay, it's when IPv4 actually exhausted, we heard from so long that it's been finished. What's the delay in migration traffic on IPv6? Who will take this? Ahmed, you're smiling. You want to take it? Or Carson? Who will answer? Who will take this question?
Okay. I'll take this one. So basically, it would be a pity to run two internets at the same time. IPv4 internet and IPv6 internet. We know we can control more or less the IPv4 internet, but using NATs destroys security. So we have a lot of cyber issues around IPv4, and we don't want to drag that into IPv6, especially into new networks like 5G, cloud down the road, and so on and so forth. So you want to have a clean slate approach to the networking. IPv4 was a research, and it is still a research protocol. And IPv6 is the real production protocol. So the US government has sent a policy request that by 2022, they would like to have 20% IPv6 only networks, and by 2025, 80%. So in order to move the entire US government into IPv6 only, knowing the benefit that they would have, okay? So we should not create another digital gap between V4 and V6. We have to get everyone on V6 in order to be all on the same level. Otherwise, we have the have-nots still in IPv4 and the rich that are going to use IPv6 in order to become richer. Okay, so this is really a very important topic, especially for the SDG call, to get the internet to everyone and give them the same opportunity.
Thank you very much, Latif. And now we'll go to polling. It's let me end the polling because it's interesting that we have 60% of our participants voted, which make it one of the best people like to vote. Okay, I will close the vote on 22nd. Please, if anyone to vote, we have to vote now, and then we'll go with the result. Oh, 3 participants raise hand. Oh, we said no more questions, please. Okay. Okay, someone want to talk? We'll take one question. Meanwhile, we're ending. Okay, Yuan, can you talk? I allow you to talk. You can send your question.
Even in a physical meeting, it takes a lot of time to get somebody to speak.
Okay, anyway, let's stop it. Anyway, already I said no more questions for today. Okay, I have to end the polling now and go for the result. So please stay with us. Okay, we'll start by first question. What IP network does your organizer company use now? We have 46%, they said IPv4. 1% only IPv6. IPv4 and IPv6 combined is 53%. So it's interesting. So we still need time to migrate from IPv4 to IPv6.
No, it's a very good number. It's not.
Yeah, no, yeah, it's not bad, of course, 53%. Anyway, we will share all this result with all of you if you like later. Okay, second question. Will your company deploy or migrate to IPv6 networks recently? 85% they said yes. And 15% they said no. And the first question is, do you agree that government should encourage the development of IPv6 and IPv6 Plus?
Absolutely, yes.
100% the vote say 100% they say yes.
Yes, because it's the biggest.
Everyone agrees. So, Ahmad, we count on you. You represent the government and ITU Bilal. Okay. So I would like to thank you, each of one of you, because really you did a great job. I'm happy we have very great speakers like you. And in fact, we have a lot of interactive participants, we don't see for a long time, people that keep asking, even till now, as you see, we have questions we cannot answer, but we cannot keep you more. I know you are all busy. Thank you very much. We will share with you all the details. You have my email, you have my contacts. Thank you very much. If any of the speakers want to say any word, please go ahead.
No, just thank you, Tony. This was a good opportunity to get an update on IPv6 worldwide.
Thank you, Tony. Congratulations. Very good meeting.
Okay.
Thank you.
Okay.
Thank you, everyone. And we have even some chat from the participants. They said, thank you. They are enjoying, a lot of people enjoy it. Okay.
We count on these people to help out.
Okay. Thank you very much. And, we're still receiving thanks from the participant. Okay. It's really, as I said, one of the most interactive webinars. Okay. Because
Tony, somebody's asking for a group picture.
I guess my team is taking picture all the time, Bukhar.
Okay. It's on the chat. It's on the chat.
Ah, really? Okay.
Yes.
I'm not reading. This is a problem. Great session within short span of time. Okay.
Tony.
Who will take picture now? We'll take pictures. Stay with us. I will take one. Anyway, good idea. Whatever from whom. Yeah, I'm happy that you're smiling. Such successful webinar needs more pictures. Okay, my team also is taking picture all time. We will have a big press release coming today, and also in the newsletter of Telecom Review. It will be in all the edition globally. So you will see a lot of coverage for this webinar for next week. And really, thank you, and keep in touch. Thank you.
Thank you, Tony.
Take care.
For now,
Okay.
everyone.
Bye. Thank you.
Thank you all. Bye.
Thank you. Bye.